Okay. Now we discuss last part of this our session, that is the plane. This unit is most important unit of this three-dimensional structure. Now we discuss theory of this plane and some examples related to that. We discuss theory related to this. Now we discuss the equation of the plane. Equation of the plane. Equation of the plane, which is brief theory of this one, is available in textbook also, but we summarize that in one table and presented like this. Given vector equation and Cartesian equation, these are the two types. Given data contains if the firstly point A is given on the plane and n cap is the unit vector or the unit normal vector to the plane, because of plane equation of the plane is represented by using normal and points in three-dimensional structure. Therefore, this is a normal form, that is the r bar dot n cap is equal to p, where p is a perpendicular distance from the origin. Now, Cartesian equation is just a conversion. One equation is already present in this whole column, that is the ax plus by plus cz plus d equal to 0, because of we use firstly vector equation and transfer into the Cartesian, which is simple. Okay. Now, second case is that if a bar be the given point and n bar be the normal vector, then our target is to find equation of the plane. Formula is like this: r bar dot n bar is equal to a bar dot n bar. Remember that r bar dot n bar is equal to a bar dot n bar, and when we simplify this one, then we can obtain such type of the equation, that is the in Cartesian equation ax plus by plus cz plus d is equal to 0. Okay. Now, our target is to find equation of the plane. In the third case is that when three non-collinear points are given, that is the a with the position vector a bar, b with the position vector of b bar and c with the position vector of c bar, then that equation of the plane is given by same r bar dot n bar is equal to a bar dot n bar, where n bar is equal to ab bar cross ac bar, ab bar cross ac bar, and second is that the option AB bar cross AC bar we obtain from the B bar minus A bar and AC bar from the C bar minus A bar. We are well known about that. Now, fourth option is that when the point A bar is a given and two parallel vectors, these two parallel vectors related to the plane, these P bar and Q bar parallel to this plane, and in such case when this P bar and Q bar are parallel, then these two are perpendicular to normal, and perpendicular vector to the P bar and Q bar is always P bar cross Q bar. Therefore, equation of the plane becomes r bar dot n bar is equal to a bar dot n bar, but n bar is nothing but P bar cross Q bar. Just use conversion for the Cartesian equation. When two planes are given, P1 and P2, and our target they are intersect with each other, the combined equation is that P1 plus lambda P2 is equal to 0. In Cartesian form, we represent like this: A1x plus B1y plus C1z plus D1 plus lambda into A2x plus B2y plus C2z plus D2 is equal to 0. This is the equation of the plane in short. Like the in table, we use the 5 cases related to this one. First is the normal form, second is the point and normal vector, third case is the three non-collinear points, and the fourth is that point and parallel vectors, and last one gives us that related to the intersection of the two planes. Now, conversion is most important thing in this line and plane. R bar dot n bar is equal to a bar dot n bar is the equation of the plane, then ax plus by plus cz plus d is the equation of the plane is equal to 0 also here. Now, just n bar comes at the a, b and c, that is coefficient of x, y, z. A bar dot n bar is must be related to the constant. Therefore, after simplification a bar dot n bar we reach at the d. Therefore, most important thing is that choose n bar from coefficient of x, y, z and d bar by just the multiplication of the point and normal vector dot product. Angle between P1 and P2. Angle between P1 means P1 is the first plane and P2 is the second plane. Cos of theta is the n1 bar dot n2 bar upon n1 n2, just a simple formula we use regularly. Angle between line and plane, this is the most important thing, just use the DRS or the parallel vector b bar dot n bar is equal to divided by b into n, that is sin theta is equal to b bar dot n bar upon bn, that is the b bar related to the DRS of line and n bar related to the normal of the plane, DRS of the normal of plane. Now our target is to find distance of a point from the plane. One point is given x1, y1, z1 and plane is given ax plus by plus cz plus d is equal to 0. Then our target is to find distance of this point from the given plane is that ax1 plus by1 plus cz1 plus d upon root of a square plus b square plus c square. Just to check that, we just replace x, y, z by the x1, y1, z1, that is the coordinate of that one, and we obtain the distance. Also one most important thing for this plane, equations in terms of the planes, equations in terms of the plane. Check that this is the part of line. When our target is to find equation of x axis in terms of the plane, then we write like the y is equal to 0, z is equal to 0 and y axis as a x equal to 0, z equal to 0 and z axis as a x equal to 0 and y equal to 0. Okay. Theory is like this. We discuss firstly equation of the plane. This is the most important chart. Keep as it is. Conversion of this one, that is the vector equation and Cartesian equation. Angle between the two planes, angle between line and plane, distance of a point from the plane and the equations, that is the x, y and z axis in terms of the planes represented like this. This is the theory related to the plane. Okay. Some points also available here, but we discuss in the questions also. Okay. Example number 1, equation of the plane which bisects the join of A 3, 7, 12 and B minus 5, minus 3, minus 2 at right angles is equation of the plane. Our target is to find equation of the plane, which is like this, and one point is on the first side and other on the second side. Now my target is to find equation of the plane, but equation of the plane is present on the DRS of normal and point which is present in this one. Now my target firstly to find DRS of normal, which is given or the represented in the diagram. A is equal to 3 plus 5, B is equal to 7 plus 3, C is equal to 12 plus 2, that is A is equal to 8, 10, A is equal to 8, B is equal to 10 and C is equal to 40. Now this plane bisect line segment AB, therefore intersection point is a midpoint of these two, therefore midpoint is the first 3 minus 5 divided by 2, that is minus 2 by 2, similarly 4 by 2 and similarly 10 by 2, that options are 1, 2 and 5, that are 1, 2 and 5. That is, this is the x, y and z, these are the x, y, z coordinates. Now target is to find the equation of the plane. Point is available, DRS of normal is also available, therefore we write r bar dot 8, 10, 14 and 2, 5, 4 dot 8, 10, 14. Okay, r bar dot 8, 10, 14 and when dot product is the 8, 20, 70, that is r bar dot 8, 10, 14 is equal to 98. When we simplify, r bar is nothing but in 3-dimensional structure xi, y plus yj plus zk, and after dot product or the transformation of this one into the Cartesian equation, 8x plus 10y plus 14z is equal to 98. We divide this equation throughout by 2. We can obtain 4x plus 5y plus 7z is equal to 49, and it is nothing but the option A. Okay. Now we discuss example number 2. The equation of the plane, question is like this, equation of the plane passing through the point minus 1, 3, 2 and perpendicular to the planes x plus 2y plus 2z is equal to 5 and 3x plus 3y plus 2z is equal to 8 is, and options are available here. Now this question is like this, the required plane must be passes through minus 1, 3, 2. Therefore, this minus 1, 3 and 2, when we put in the value, add the value of x, y and z, then that satisfies this equation, this point satisfies the equation. Now, and this required plane must be perpendicular to the first and second plane. Therefore, verify the option where minus 1, 3, 2 available in this plane, that is LHS is equal to RHS in that equation. When we put x minus 1, y is equal to 3, z is equal to 2 and LHS is equal to RHS, then that point is present on that plane, and verify the condition of the perpendicularity. Means what? That is this option, when we take the perpendicular, this first plane and first option, we just choose the first option, this plane and this one is the perpendicular, then DRS multiplication A1 A2 plus B1 B2 plus C1 C2 is equal to 0. You check that for the both and verify them, and when this first condition and second one also satisfies to this any option, and then that option must be correct. In this question, A is the correct solution. Therefore, you also check for the others, it is not possible to satisfy these two conditions. Okay, next one. Okay, now we come to the example number 3. Check that question. Equation of the plane passing through the point 0, minus 2, 3 and containing x-axis is. Very interesting question. It's very short question. Equation of the plane through this 0, minus 2, 3 means that plane passes through this point and containing x-axis. Options are given here. That is the 2y plus 3z equal to 5, y plus z is equal to 1, 4y plus 3z is equal to 1 and 3y plus 2z is equal to 0. Firstly, use plane containing x-axis. If plane contains x-axis, then that plane must passes through origin, because of x-axis also passes through origin and plane passes through this x-axis, therefore that plane passes through the origin. And when this, they check the option which satisfies the 0, 0, 0 condition, then that equation must be the required equation. And such question is that there is the 5, 1, 1, it is not a possible, and which is the possible, that is the 3y plus 2z is equal to 0. And one another thing related to this containing plane x, that is when plane passes through x-axis, which equation of the plane, in the equation of the plane there is no term of the x, this is also hint related to this one. Now example number 4, equation of the plane passing through the 2 points 2, 3, 1, 4 minus 5, 3 and parallel to y-axis. Very interesting question. Options are like this: x plus y is equal to 5, y plus z is equal to 4, x minus z is equal to 1 and y minus x is equal to 1. Plane parallel to x-axis. Plane parallel to x-axis, then equation of the plane contains no term of the y, that is y is absent in the equation. Therefore, you check that all options, out of them option C is possible, because of it this equation, in this equation no term of the y. Okay, but for the next simplification we check this. If the two options are like this, there is the single option but sometimes repeated, then you check these 2 points, put these 2 points and check the LHS and RHS. Then we obtain first, for the first point 1 is equal to 1, for the second point 1 is equal to 1, that is both points satisfies this equation, also satisfies the parallel condition with the y-axis, therefore option C must be the correct solution. Okay. Example number 5, this question is like this: equation of plane passing through the 2, minus 1, 3 and making equal intercepts on coordinate axis. equal intercepts on coordinate axis. Very interesting question because of it is the intercept form of the plane which is not discussed in theory, but remember that intercept form of the plane is like this: x upon a plus y upon b plus z upon c is equal to 1, where a, b, c are the present on x axis. Okay, intercept form of the equation of the plane passing through this point making equal intercepts on coordinate axis. When this equation made the equal intercepts, then denominator must be repeated, that is a, that is x by a plus y by a plus z by a is equal to 1. Therefore, x plus y plus z is equal to a. And most important thing is that this 2 minus 1 3 is present on that plane. Therefore, this equation satisfied by this point. Now 2 minus 1 3 put in this equation, that is 2 minus 1 3 is equal to a. Therefore, a is equal to 4 and required equation gives us that x plus y plus z is equal to 4. Very interesting question. Okay, in such type of the question we use the techniques, but firstly simple formula and other technique is the second technique is most important for the fast output. We can obtain easily solution using such type of the techniques. Example number 6. Now check that. A plane meet the coordinate axis in ABC if the centroid of triangle ABC is a small ABC. This is the point now. The equation of the plane, options are given here. Now we discuss solution and then going to the options. Check that capital A, capital B and capital C are the intercepts on the x-axis. Is it correct? Therefore, on the x-axis, coordinate of the A is must be x1 0 0, coordinate of B 0 y1 B 0, then the C 0 0 z1. Now therefore, x intercept is equal to x1, y intercept equal to y1, z intercept is equal to z1. Our target is to find centroid. Therefore, by centroid formula, x1 plus x2 plus x3 divided by 3 means x1 by 3. Similarly, y1 by 3. Similarly, z1 by 3. This is the centroid of that triangle. Now, but okay. Now discuss example number 6. A plane meet the coordinate axis at the ABC if the centroid of triangle ABC is the small ABC. This is the point, remember that. Then the equation of the plane is, there are 4 options. We discuss them here. Firstly, question is that A, B, C are intercepts. Therefore, A present on x-axis, B present on y and C on z. Therefore, coordinate of the A is the x1 0 0. B is the 0 y1 0, C is the 0 0 z1. Therefore, x intercept x1, y intercept y1, z intercept z1. Now, you remember that ABC be the triangle and this small ABC gives us the centroid. Firstly, we find centroid of this triangle here. Therefore, centroid of triangle x1 plus x2 plus x3 divided by 3 gives us that x1 upon 3. Similarly, y1 upon 3. Similarly, z1 upon 3 related to this. This is the centroid formula, but already one centroid is given, that is the ABC. This one and this x1 upon 3, y1 upon 3 and z1 upon 3 are equal. Therefore, by using this equality, x1 is equal to 3a, y1 is equal to 3b, z1 is equal to 3c. Therefore, what is the intercept plane? Equation of the plane in the form of intercept form, that is the x upon intercept plus y upon intercept plus z upon intercept is equal to 1. That is 3a, 3b, 3c present here. Multiply this equation by 3, we obtain the option A, which is available. X upon a plus y upon b plus z upon c is equal to 1. The next options are not necessary because of the simplification is like this. Okay, simplify this logically, we obtain quickly solution. Okay, example number 7. Now, our target is to take acute angle between the y-axis and the plane 5x minus 4y plus 7z is equal to 30. Okay. Now, options are given here. Solutions like this. DRS of the plane. Check that DRS, coefficient of x, y, z, 5 , 4, 7. DRS of y-axis, 5 , 4, 7. DRS of z-axis, 5 , 4, 7. DRS of z-axis, 5 , 4, 7. DRS of y-axis, 5 , 4, 7. DRS of z-axis, 5 , 4, 7. DRS of y-axis, 5 , 4, 7. DRS of z-axis, 5 , 4, 7. DRS of y-axis, 5 , 4, 7. DRS of z-axis, 5 , 4, 7. DRS of y-axis, 5 , 4, 7. DRS of z-axis, 5 , 4, 7. DRS of y-axis, 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 5 , 0, 1, 0 because of y axis y, second term is 1. What is the angle between the line and plane? Sin theta. Sin theta is equal to a1 a2 plus b1 b2 c1 c2 divided by first root into second root. But the most important thing that our target is to find acute angle, therefore there is the modulus. Okay? Therefore it is minus 4 upon 90 by using simplification, that is 25, 16, 49 addition of this one, this is the 1, therefore root 90 is available. Come outside the modulus, then 4 by root 90, theta is equal to sin inverse of 4 upon root 90 due to the acute angle. We consider this part is the positive and the option D is correct in this one. In this way we have completed plane with also 4 points are discussed or 4 units are discussed. First is the vector, second one is the 3-dimensional geometry, third one is the line, and lastly plane. We have discussed that already. Now 4 or 5 questions are compulsory available in your question paper in this section, therefore must be focused on this part, and remember that this part is the most important related to the CET and related to the JEE also. Therefore our target is to complete this part with the using also solved questions in the textbook. Sometimes CET exam solved questions has the most important part in this one in the coordinates, vector, 3-dimensional geometry, line and plane. Okay. These are the most important topics related to the CET and JEE also. So 4 or 5 questions are designed related to this one in CET exams. Therefore you must prepare these 4 topics carefully, and for this one you refer firstly for the CET 2020, you refer the textbook, solve questions of the textbook, solve questions in the textbook, which are most important for this one. Sometimes solve questions are asked made in the CET exams. Okay. Now most important thing is that in such exam you will prepare firstly theoretical part means textbook and then questions, and prepare the short notes like the chart tables and the short notes related to this particular and remember. Okay. Best luck.